The normal approximation to binomial distribution. Okay, first of all, before we do normal approximation, we have to understand what is discrete variable and continuous variable. Okay, discrete variable. Discrete means a fixed value. Okay, for we have done this in case stage 3 as well. A fixed value, for instance, how many children are there in a family? Okay, how many siblings that you have in a family? Okay, maybe 3, 4, and so on. It's a fixed value. Number of medals awarded at Olympic Games. Okay, something that we can count. Okay, 3 golds, 2 silver, and so on. Number of hits when flipping 3 coins. Again, same thing. Okay, you can have 2 hits or 1 hit, 2 tails. Okay, whereas continuous variable are not a fixed value, not something that you can count, but you can measure. Okay, for example, height of a student in a class. Okay, they might be 1.75 or they might be 1.35. Okay, time it takes to get to school. Okay, it could be 2 hours 10 minutes. Okay, or 15 minutes and 30 seconds. Okay, temperature of a city. Okay, temperature of a city could be 27 degrees and zero point 0.5 degrees. Okay, 27.5 degrees or 15.2 degrees. Okay, so these are not a fixed value. It's a measurable value, but it's not a fixed whole number. Okay, so let's say if I toss a coin. Okay, let's say if I toss a coin. When we toss a coin, there are only two probable. Okay, two possibilities that can you have, which is 0.5 to get an hit, or probability of getting hit is 0.5, or probability of getting a tail is 0.5 as well. Okay, these are the two possibilities. Let's say we have 4 coins. Okay, let's say we have 4 coins, and then I'm going to list down a sample space. Okay, I'm going to toss each coin. Okay, and once I'm done with 4 coins, I'm going to list down all the possibilities that I can have. Okay, and when you do that, these are the possibilities that you will have. Okay, the first one, tail, 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 or hit, or tail, tail, hit, tail. Okay, tail, hit, tail, tail, and so on and so forth. If you count all that, okay, you have 16 possibilities. So if I toss 4 coins, one of these 16 will definitely happen. Okay, so these are these outcomes. Next, okay, when I talk about outcome are basically results. Okay, once you have flipped 4 coins. Okay, or what are the possibilities that you can have, or 3 coins. Okay, for whatever a number of coins. Events, whereas, okay, I want to know out of that 16 possibilities how many two tails. Okay, how many possibilities or outcome that has 2 tails. So that's an event. So we just talk about one specific event. Okay, now 4 tails. Okay, and 3 tails, 2 tails, 1 tail, and no tail. Okay, x is the number of tails from 4 tosses. Okay, now I want to find out what is the probability of getting 4 tails. Okay, if you look at it from the sample space. Okay, if I list down, if you guys list down as well something like this, you should get, to get 4 tails, it's 1 over 16, which is tail, 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 tail. Whereas to get 3 tails, okay, then you have 3 tails, 1 hit. Okay, so which is over here. Okay, which I can see over here. Okay, so you have 4 outcomes as well. Okay, it's only the order is different. Okay, whereas 2 tails, you have 16 outcomes. 2 tails. Okay, that's 1, 2, 3, 4, 5, 16 outcomes. And then 1 tail, again you have 4 over 16. Okay, 1 tail meaning 3 hit. Okay, 3 hit, that's 1 and 2 and 3 and 4. And finally, no tails at all, which is all 4 hit, which is this one over here. Okay, so now, now let's illustrate this as a graph. Okay, if I illustrate this as a graph, okay, your y-axis represents the probability. Okay, and your x-axis is the whatever the outcome that I want. Okay, no tail at all, you can see that's 1 over 6. 1 tail, it's 4 over 6. 2 tails, 6 over 16. And 3 tails, 4 over 16. And 4 tails, again 1 over 16. and you find that it is a symmetrical distribution. Okay, I can draw here. It's somewhat a bell curve. It goes up and comes down. Okay. Okay, this time we only managed to do 4 coins, and that's why we only have 4 bar charts over here. But what if I have, or histogram? Okay, what if I have more? Okay, as the number of trials increases, the binomial distribution approaches the normal distribution. The normal approximation to the binomial distribution is very accurate when n is large. Yeah. Okay, let's look here. That's 100 trials. Okay, and that's 400 trials, and that's 900 trials. Okay, so you can see very clearly that the more trials that we do, the accurate our value is going to be. So, and not just accurate, we're going to get a curve that is exactly like a bell curve. Okay, so we're going to get a curve which is a bell curve, which is known as normal distribution curve. Okay, so now approximating to normal distribution. Continuity correction. It is used when you want to use a continuous distribution to approximate a discrete distribution, typically used to approximate binomial distribution or Poisson distribution when normal distribution is used. Okay.